Hello everyone, so today we are going to start with a discussion of the new topic 12, heat conduction and thermal expansion. But for this session we are going to focus on 12.1 heat conductions. Okay, so before we go further about what is meant by heat conductions, we have to recall our prior knowledge, what is meant by temperature and also the heat. Temperature we represent by a capital T. It is defined as the fundamental quantity, or we call it as basic quantities, that measure the degree of hotness of bodies. Okay, it actually is a measurement of the hotness and coldness of a body. Normally for a hot bodies, we are going to have high temperature. And for a cold bodies, normally we have low temperature. SI unit for temperature is Kelvin, but we also can express in other units like degree Celsius and also degree Fahrenheit. Okay, so the second terms that we need to recall is heat, Q. So heat is defined as the energy that is transferred from one body to another because of a difference in temperature. So heat actually is energy that transferred when between two bodies there is a difference in temperature. So heat will always transfer from hot regions, high temperature, to cold regions, low temperature, until the thermal equilibrium is achieved. Thermal equilibrium is achieved means when there is no difference in temperature between two bodies, there will be no heat flow. There will be no more heat transferred. Okay, so heat only transferred when there is a temperature difference. Okay, because heat actually is energy, so the unit for heat Q is joule. The SI unit for heat Q is joule. Okay, so we say that heat will transfer from one body to another because of difference in temperature. So we have what we call thermal conduction or heat conductions. What is heat conductions or thermal conductions? So class, so we say that heat will be transferred from one body to another when there is a difference in temperature. So one method of how heat is being transferred is what we call heat conductions, or we call it also as thermal conductions. Okay, so thermal conduction or heat conduction is a process where heat is transferred through solid from a regions of high temperature to the regions of low temperature. You might refer to the figure below. For example, this one. I have a rod. Left end, I heated the rod at the left end, so it's at high temperature. Another end, the right end, I hold it whereby the temperature is low. So there will be heat conductions, or there will be heat transferred through conductions from the high temperature to low temperature. From high temperature to low temperature. So that through a solid, that one we call heat conductions. Okay, so since we know that when there is a temperature difference, so there will be heat conductions lah. So the heat will transfer from high temperature to low temperature. From high temperature to low temperature. But then if you have a rod and both ends have the same temperature, equal temperature, then there will be no heat transfer. There will be no heat conduction occurs. You won't have any heat conductions lah. Alright, there will be no heat conductions if the temperature is equal. So remember, conductions only occurs when there is a temperature difference between the both ends. One end is at high temperature, another end is at low temperature. Okay, so I guess I have explained quite well what we means by heat conductions. There must be a temperature difference. Okay, so if this one is the rod, if this is our rod, if this is a rod, this is our rod, or any solid lah. For example, this is a rod. The left end is at high temperature, is hot. Is hot mean is at high temperature. For example, 100 degrees Celsius. The right end, another end is cool. I label it at T final, T subscript F, T final, whereby is at cool means is at low temperature. Is at low temperature, for example, 20 degrees Celsius lah. Okay, so the heat will transfer, the heat will flow. There will be heat conduction from the high temperature, hot end, to the low temperature, cool end. Okay, they travel a distance, the heat travel a distance of x across an area of A. Across an area of A. So the heat flow from hot end to the cold end. So the heat is transferred, the heat is flow. So maybe we would like to know how fast the heat is being transferred. So how fast the heat is being transferred is what we call rate of heat flow. Rate of heat flow. That one is how fast the heat is being transferred. That one you call rate of heat flow. It's represented by dq over dt. dq over dt. So how fast? You said the heat is transferred from high temperature to low temperature. The heat is flow from high temperature, hot end to the cold end. So how fast it flow? Berapa laju haba tu dipindahkan. That one you call rate of heat flow. So the equation to calculate the rate of heat flow is dq over dt equal to negative Ka dt over x. Okay, so this is the equation to calculate the rate of heat flow, whereby dq over dt is what we call rate of heat flow, or we call it also as thermal power. The unit will be watt. Power, right? Power watt. Because heat is energy. Energy divided by time taken. We learned it in chapter 5. Energy divided by time is power. So sometimes we call it as thermal power also. So the unit is watts lah, or we have joule per second lah. Joule per second. Okay. Then A is referred to the cross-sectional area. The unit is meter squared lah. So calculation in SI unit. dt is the change in temperature lah, because your heat flow from high temperature to low temperature. So there is a temperature difference between the hot end and the cold end. So dt represent the change in the temperature lah. It might be expressed in degrees Celsius or Kelvin, doesn't matter. It can be in degrees Celsius or Kelvin. So how you find the change in temperature? So change in temperature is T final minus T initial. Okay, T final minus T initial, whereby the T initial is the high temperature, T final is the low temperature. Why? Because we flow from the hot end to cold end. From heat flow from high temperature to low temperature. So this is final, this is initial. So we will take the final 20 minus 100. 20 minus 100. Okay, final minus initial. X represent the distance traveled by the heat lah, or we call it as length, or we call it as length. Okay, we call it as length. The unit for sure is meter lah. Is meter. If we take dt over x, the whole terms dt over x is what we call temperature gradient. The unit is Kelvin per meter, or we have degrees Celsius per meter. Okay, temperature gradient. Okay, so K represent what we call thermal conductivity. Thermal conductivity. The unit will be watt meter per Kelvin, or we have watt per meter per degree Celsius. That one is the unit for K, thermal conductivity. So K depends on the type of material. Our value of K depends on type of material. It means that the value of K for steel is not equal to the value of K for plastic or glass. Why? Because steel and glass is different material, so they are going to have different value of K. So K depends on the type of material. If the value of K is large, high, it means that it will be easy or faster to conduct the heat. So normally good conductor will have higher value of K compared to poor conductor, or we call it as insulator, penebat, insulator. Okay, so insulator will have a very small value of K Good conductor will have very high value of K. And then you will notice that, class, you will notice that a very important thing in the equation is we have a negative sign. Do not ever left out the negative sign. The negative is a must. The negative sign is a must. Why? Because the negative sign indicates that the heat will always flow in the direction of decreasing temperature. Decreasing temperature. Betul kan? The heat is transferred from high temperature to low temperature. So the temperature is decreasing. See, your heat is flow in the direction of decreasing temperature. Decreasing temperature. So it must have a negative sign because your heat always flow in the direction of decreasing temperature. Konsep dia sama macam air yang mengalir. Air selalu mengalir daripada kawasan yang tinggi turun ke kawasan yang rendah. Okay, so berkurang. So our heat always transfer from high temperature to low temperature. So class, from the equation given, this is our equation. Remember this equation. Okay, so our rate of heat flow depends on the cross-sectional area, whereby you will find out that the larger the area, the faster the heat transferred. Okay, the larger the area, the faster the heat transferred. Second one, it will depend on the temperature gradient through the cross-sectional area. Means that if the difference in temperature is large, if the difference in temperature against the distance is large, the temperature gradient is large, then the rate of heat flow also will become large. Then the last one, it depends on the type of material. Type of material means the value of K, the value of K. So if the K is large, means our rate of heat flow also will become faster. It will become faster also. So basically class, when we have heat conduction occurs along a rod or any material, then we can calculate how fast the heat transferred by using this equation dq over dt will be negative Ka dt over x. Okay, this is the equation we use to determine how fast the heat is being transferred. If we have jointed rod, means if we have two combination of two rod, we have two rod of different materials, we combine it, then how we find the thermal conductions? So if the rate of heat flow is in steady state, we will find out that the rate of heat flow along the both rods are the same. So the rate of heat flow in rod X will always equal to the rate of heat flow in rod Y. Okay, so this is the key concept. This is the key concept for jointed rod. Jointed rod means combination of two rods. Combination of rods but we only have two rods only. Okay, we just combine two rods. Okay, so the temperature in this end, for example, is hot. whereby we have high temperature here, and at the other end, this end is cold at low temperature. So the heat will start to flow from the hot end towards the cold end. So the rate of heat flow for the two material, these two rods, will always be the same lah. This is the key concept for jointed rod. So use this key concept, we can find the temperature at the adjoint end. Adjoint end means the end hujung yang kita sambungkan dua rod tu. Hujung yang kita sambungkan dua rod. That one kita panggil sebagai adjoint end.